Hey there, hope you're doing well. Michael here. All right, one thing I find that's important in teaching, learning, and thinking, something we all do whether we're in school or not, we'd have to do as part of our adult human life, as part of human life in general, I should say. Wherever we turn our minds to think, we think all kinds of different areas. We need to know how to do it well. The better we can think, the better we can live. But one thing I find in teaching that's very important is using examples. Examples help students form concepts and gain understanding. It's the same regardless. We're all teachers and students in different ways all through our lives. Situations where we teach, situations where we learn from other people. So even though we're not in school, those things still come up regardless, no matter how old we are or whatever. We need to know how to do them well. That should be an important part of education. Learning how to teach, learning how to learn, learning how to think properly, because thinking is at the root of both of them. But examples are critical, no matter what. Like I say, we need them in life, we need them at work, not just school. So, whenever you're doing stuff, learning things in school or out, getting concepts, acid, base, titration, redox, oxidation, reduction, redox equations, quantum mechanics, Maxwell's equations, the Navier-Stokes equation, turbulence, government, psychopath, discipline, friend, money, honesty, integrity, reason, logic, induction, deduction, wisdom, things you got to think about regardless, things you need to know, concepts you need for whatever you do for a career or work, things we need to know in life. We need to be able to recognize and really know friend and really know integrity. Just look what happens when we don't grasp whether someone's really a friend or not, whether they really have integrity or not, whether they're really honest or not. Those are some important things. And then, the better you understand what you're doing at work, of course, the better job you can do. But I'll look at a few simple examples that are accessible to everyone. We all have our specialized areas where there's, certain concepts we need to know that a lot of other people don't. You study something maybe in tennis versus football, what the world in general calls football, not American football. Different specific concepts there, whether you're playing or coaching or whatever, and piano versus flute, and BJJ versus karate or whatever, or even in different aspects of math. There's math in general, but people specialize in certain things, same thing in physics or whatever. So there's a lot of stuff that doesn't apply to people in general. I'll talk about some simple examples, things I've actually done and seen when I've been teaching. I've noticed that, as I say, examples help students form a concept and they help them understand it. I've seen that in teaching some grammar, some sentence diagramming, and teaching some physics. So with grammar, there's people who, of course, we can talk and speak and people understand, to some extent, a good extent, what they're saying and mean, but we should learn in education grammar. You don't got to go all in depth about it and be masters of it like some people who study it in college, get a PhD or whatever, but we should also have a good basic understanding of it, because it's about how we put concepts together which is, important for thinking and communication. Sentences, phrases, paragraphs. As some people say, grammar's part of logic because of that. But in teaching some grammar, I noticed that if all you do is give someone a little rule, an adjective is a word that modifies a noun, they don't get it. Of course. Some people do because they got the background and context and they got the examples in mind and habituated already, but a lot of people don't. So examples help them see what a word actually is and how to classify it and categorize it. Examples are an important part of doing that. If all one has is these phrases, these little rules, without context and examples, they're hard to follow. Like a projectile is something that has an initial force and then it gets pulled by the earth. So it's like, what the hell are you talking about? Like, what things, and in contrast to what? What's the context? It's like, what? Whereas if I say a projectile is a rock that you throw or a cannonball that you shot, there you got real content. You can think about something. It's in the world. You got it independently. You can start to study it now. Okay, that is a good example of the importance of examples. How it helps us think. Or an adjective is blah, blah, blah. It's a word that modifies a noun. Well, what the hell do you mean? Like, modifies a noun? Like, so am I an adjective because I can, modify nouns? Or if you write down the word dog in blue and then erase it and make it red, you've modified a noun, or your pencil, an eraser has. So is a pencil something that can modify a noun? No, we need the right context and so on. And so here we're thinking about logic, not about being silly. So hopefully you're grasping what I'm saying. We got to put it in the right classification. If someone says an adjective modifies a noun, then you're not seeing what kind of thing you're talking about. There's an absence of causality and context. It's just a floating idea. No. An adjective is a word that modifies a noun. When you say it's a word that modifies a noun, you're focusing your attention to a certain context, to language, not to things in general. An adjective modifies a noun. It's like, what kind of thing that modifies a noun? You're leaving the whole entire realm of thought and reality open. It's known not to be a good definition. There's rules of definition. A rule of definition is a good definition must identify a genus and species. Otherwise, it is not at all a good definition. It's vague and does not lead to clear thinking focused on reality. But we need examples. And as I say, if I just give someone a word phrase, or if it's done in school or whatever, people have trouble learning an adjective. I've taught people who, in sentence diagramming and all that, they've already gone through, quote unquote, teaching about some of this, but they don't get it. And it's just because the methods aren't right and people need to understand good thinking skills more. So use examples to do it, not just phrases or linguistic definitions that don't have anything to do with the world. Get the definition from the examples and from the world. Don't get it out of nowhere. So when we're doing this, so stop and think, okay, we said a little bit about that. Now some context, adjective. Notice that to get the idea of adjective, someone already has to know language. They've been speaking, they've been using language, they've been using nouns and verbs, adjectives, adverbs, without knowing what those things were. Because grammar is a higher level abstraction than just using the words. You got language, you're talking about things outside yourself. With grammar, you got to start looking at your mind and seeing what it's doing, seeing what your thoughts are doing and how thoughts relate to each other. You can look outside yourself and see the green grass, the grayish tree, and so on. The focus is external. But to look at my words and my thoughts is entirely different. That's a different focus, a different context, a different level of abstraction. So we already have to know some actual nouns and verbs and adjectives and adverbs and sentences and all that to get to this in the first place. Because, you can't form a concept of something you don't know anything about. If you don't even know what a noun or adjective is, you can't, if you have no examples, you can't form a concept, properly speaking. So people have been, this is a context where people have been talking and thinking in language so far. Then one can learn these. But I'll write down some examples for them. And I'll put these notes in like the description field so you can look and see it for yourself. But when I write down, like for adjectives, red, blue, fast, slow, wise, unwise. Write down his, hers, theirs. Because you can say the blue dog, the red dog, the wise dog, the unwise dog, his dog, her dog, their dog, or 3 dogs, 5 dogs, that dog, this dog. So these, we can write these down. Here are our adjectives. And then can write down some nouns, write down some verbs, write down some adverbs, write down some prepositions, give examples of some things. Then if we're doing something that says, those dogs ran away. And we say, okay, what is the part of speech those? Does it modify a noun? But modify a noun is too abstract for a lot of people. Like, what the heck do you mean by modify a noun? But if we say, okay, look at the list. Those. Which words is those most like? Those. Is that like cat or steak? Nope. Those. Is it like run or throw? Nope. Those. Is it like this, that, those? Yeah, that makes sense. Cat, human, steak, wisdom, those just doesn't fit. Feel, run, throw, those just didn't fit. But this, that, those, yeah, that's the same kind of thing. And those are adjectives. So, those is an adjective. It's helped so much. Then people can start to build it up. They get this stuff habituated. They know what the examples are. Then saying an adjective is a word that modifies a noun makes sense. They've habituated the comparison, the differentiation. And so there's real meaning behind an adjective is a word that modifies a noun, instead of it being some like floating thing out of nowhere. That's helped a lot. Or when you get into something more abstract, like the dog on the corner was barking. The dog under the table was barking. Under the table? Under, that's like a place. That's like an adverb. Wait, is it the dog under the table? What is under the table doing? Is that telling us about what it did, the barking? No, it's telling us which dog. So the dog under the table. That dog, we're specifying the dog, not some action. So it's an adjective. They can start to think like that. The focus is on the dog and describing it, just like this other stuff is. And they see under the table in this case is more like the small dog, the fast dog, this dog, that dog, than it is like any other part of speech. Because you got adjective phrases, adjective clauses, and to go from a word as an adjective to something more abstract as an adjective takes that strong foundation in the first place. Really getting specific adjectives and what they do. See that function in a thought, and then seeing how this prepositional phrase can be an adjective also. So much. And instead of just a word phrase, I find some questions too. Like there's the adjective questions and the adverb questions. I do that sometimes too. We go through a list. Okay, here's this word. You think it's an adjective, so the adjective questions are which ones, what kind, how many, whose. And again, folks, I got these in the description field so you can look. But, so tell me, this word, does it tell which one of the dogs? No. Does it tell what kind of a dog? Like red, intelligent? No. Does it tell how many dogs? 3, most, all, some, 5? No. Does it tell whose dog? His, hers? No. So we thought it was an adjective. That's fine. We're not right all the time. We got to learn, but it's not. So what about the adverb questions? Does it tell how something happened? Yeah. It tells how about this verb. So, oh yeah, it's an adverb, not an adjective. So these questions help also. Having examples to help classify. And then once you get that down, you got to have the examples. Then you see, oh look, adjectives can do different things. All these things modify nouns, but they can do it in a different way. They can tell us which one, or what kind, or how many, or whose. But you got to have the examples there in the first place. It's not like magic, like out of nowhere. Oh, there's these things called words, which you know nothing about, to tell which one, what kind, how many, and whose. Okay, they're adjectives, Meaningless, no content to it whatsoever. We need content. We need examples. So here's some ways that examples help, as I say, and that'll help in other things, no matter what you're doing in life. So we look here, some things we see in this simple example are looking at adjectives. It's a simple example, but think, okay, when you're looking at some other idea in school, learning, teaching, at work, think about what are examples for the thing you're talking about. You want to form a concept. What are the things? How are they similar? And how are they different from related things? And that's they kind of go together. You don't really have similarity and difference in this way separate. You see similarity amongst certain types of words amidst the background of other types of words. It's like you can't have one without the other. Adjectives aren't similar out of nowhere. They're similar as words, only in context of words in other parts of speech. So that's one thing that's critical about some of this. You look at one thing in contrast to other causally related things of a similar nature. So we got these examples of adjectives. We see how they're similar. We see them in contrast to adverbs and nouns and verbs. We see that we can't have adjective without noun because an adjective is a word that modifies a noun. And, we got to have verbs too because a sentence is a complete thought and it's got to have a noun and a verb. So that's a basic structure. Noun, verb, then start adding other descriptions into it. Adjectives, adverbs, clauses, phrases. But the noun and verb is the kernel of the thinking, of the thought. And then, so the similarity and difference, the contrast, they go together. And then you got a certain context. This is in context of language, knowing this stuff already. Um, all right, and then with projectile, I've noticed that a lot too. Students have trouble getting what projectile motion is because it comes out of nowhere. They just do this math out of nowhere without being taught what in reality they're talking about. So I find that you got to look at certain things in contrast to others. So you say, okay, here we look at all the things that move in the air. We have rocks that fall. You can push something on the ground. Something can go like on the surface of water. There's birds that fly. There's helicopters. So it seems like rocks that you throw, cannonballs that you shoot are similar. They go out away from you. They go up and down a little bit. They don't have their own power of movement. They don't fall straight down. Or in some way like an arrow that we shoot, a bullet that you shoot, a ball you throw. Some of these things are projectiles. Something you like flick off the table. So those things, in contrast to like say something that goes on a horizontal surface or something that falls straight down, something that moves like a jet plane or a helicopter or self-propelled rocket. So you see different ways things can move in different shapes. They go different types of motion. So the rock we throw and the bullet we fire are projectiles. And then we can see that you still might think they're different. A bullet goes really far. It goes straight and then falls down all of a sudden, whereas a rock gently goes. Some people might think, well, a bullet goes in a straight line for a long time, but a rock doesn't. Or you can throw a ball up and it comes down. It takes more experience to see that they're the same sometimes. But we look at these things. We see this is what projectiles are. Then students start to understand it. So this is what I'm talking about. So it's these things in contrast to a free fall, in contrast to something rolling along the ground. So we got this concept of projectile and projectile motion. It's projectile motion, so it's a certain type of motion. How something's moving. Not in a jig-jagged way, not self-propelled, not straight down, not horizontally, but in a curvy way through the air. That's a projectile motion. And the projectile is the thing that does that. So it's an abstract classification, abstracting away from material it's made of, weight, how high it's thrown, how far it's thrown, color, shape, things like that. These are all projectiles. You got this class of things that can differ in many ways, just as adjective, these words can differ in many ways. But adjective, they all have the same function in our thinking. Adjective words, adjective phrases, adjective clauses, they got the same function. And projectile motion is all these different things, but are still similar in this way, in contrast to other types of motion. And then a context, it's not in syrup or in water or in mercury. but in the air. And then we see why. We can start to study them. Oh, we got these things. Now, we got this concept of projectile motion, this concept of projectile. And we can start to study it and see why. Because, like a lot of people know that there's these differences through experience, but they don't know it scientifically. And once you tie this physics and science to experience, it makes so much more sense and people start to get it. It's awesome. It's how we should teach. Because that's basically what Newton and Galileo did to start physics, modern physics. They revolutionized how people thought, how science was done, how the kind of logic that was applied to things to do science. That's how they revolutionized it and made modern physics. They weren't all of a sudden doing things and people were wrong before. They weren't doing the same thing. It's just Galileo and Newton did it better. Galileo and Newton had a totally different method of thought. They got it from Aristotle. Galileo himself said that, let me get my computer screen back up. Oh, wrong password. I went to sleep. There's this ugly yellow color that came up. Okay, there, now I can see my notes again. But Galileo wrote in regard to the Earth going around the sun instead of the sun going around the Earth. He said, I think there's nothing so certain in Aristotle is that all human reasoning must be placed second to direct experience. Experience is first. Reasoning comes second. Galileo and Newton both knew that. That's what we should do in our teaching and learning and thinking. Whereas St. Thomas Aquinas said, getting it from Aristotle, nothing is in the intellect that was not first in the senses. Nothing real, nothing true. So we should do some of that with teaching and learning. Look at examples. Then our focus is on the real world instead of being lost in our minds with meaningless words, empty linguistic connections, and so on. Knowledge is about the world. Knowledge isn't about what's inside our head. Of course, knowledge about psychology is about what's inside our head in a sense, but it's in the sense of what's in the world. Or, you got to look at your own thoughts to see about logic and so on. But we're, in studying induction and deduction, we're seeing what we're doing about external content. That's always the ultimate focus. You don't study induction and deduction on your own. You're looking at your own thought processes and seeing, what am I doing in thinking about the world? What am I doing in processing external things? So the external is the ultimate basic. We have to know examples like that. But once we look at examples of projectiles, then we get it. As I say, that's what Galileo and Newton did to start science, make it successful. We should be doing that in teaching and learning. Once I talk about that with students, then they get it. So we get this concept of projectile, as I said, concept of projectile motion. Then we can start to understand what it is. We see, what makes a projectile different than something in free fall? And like I say, we experience it. That's part of why I brought up Newton and Galileo. Partly for this philosophic principle there, but partly to see how we can get this idea and have some awareness without having the science yet. And the science is a different thing. It's not like, I already knew that. No, you didn't. You knew it in a way, but not conceptually and scientifically. But if we stop to think, we know from experience what it's like to push a ball along the floor. We know what it feels like. We can remember, or we can get down on the floor and do it ourselves, or just push something along the floor with our foot and focus on the feeling. versus when you drop something. You know when it's on the floor, when you push it, the total experience. You know what it's like when you hold something in your hand and let it go. You know what it's like to get a rock and throw it. There's different causes there where we know from experience. There's different context. Then we can start to conceptualize it, be more scientific, and look at causes. So far, that's just experiencing it, kind of what's happening, what it feels like, what's happening, and what it feels like. To make it scientific, we got to look at why. We got to ask and answer why. So then we can start to think, what's going on, and how do we characterize projectile motion, and how would we define it scientifically, and not just in terms of our feeling and experience? And then we see that we look at experience and see what's going on. What happens when the cannonball is fired, or when you throw a rock, or when you flick something off the table? There's an initial force, a push, and then something goes on its own until it hits the ground. That's what's the same in all these motions. That's what makes something be a projectile. It's projected. You flick it off the table. You hit it once. It goes off the table until it hits the ground. You get a rock and throw it. It flies through the air in a curve until it hits the ground somewhere. You fire a cannonball. Initial explosion. It's forced out. It goes somewhere until it hits the ground. Versus something just falls when you let it go. Or you push it on the ground. Or it's a helicopter or airplane. Or a bird. So we see that a projectile motion is motion with an initial force that then goes only under the influence of gravity until it hits the ground. And we can get that by looking at the real things. Then that definition makes sense. When you get the definition from actual examples in a context. And we do that with, we should do that with other things too. We're teaching, we're learning, we're doing stuff at work. And then to figure out what shape it goes in, that was important in learning about projectiles. The understanding, first you get the basic idea, a basic definition or characterization of it. What is a projectile? What is projectile motion? You got examples. You can characterize it. You got some like smooth arc, and it's local. As Galileo knew, if you threw a rock and the Earth suddenly disappeared, but all the mass was concentrated at the center of the Earth, then the thing would spiral towards the center. It would not be the shape it is. It would be a spiral instead of some smooth curve we see. So what curve is it? And so to figure it out, he did this experiment where, and I can explain this to students, or you can just talk about the projectile stuff. You can kind of see with some slow motion photography and stuff that it's like a parabola, semi-parabola. But the way Galileo figured it out was, okay, put your two hands together, and you got your pointing fingers next to each other, right hand and left hand together, thumbs down below. You got those two knuckles in your hand together, and that's like a tabletop. Now, leave your right hand where it is, parallel to the ground. Both hands should be parallel to the ground, by the way. And then you get your left hand and slant it down. Keep your knuckles together, but the tips of your fingers of the left hand go down towards the floor. So your right hand is parallel to the ground, and your left hand is straight, flat, slanted downwards. And those knuckles are still together. Tips of your fingers are far apart now. And he had it set up like that. So he got a ball. And get my computer screen again. There. The screensaver thing came on. So you get a ball, and you flick it off your right hand, that part of the table, let's say. Remember, we're pretending this is a table. You got a flat table. You flick it off your right hand, and then it would go onto your slanted hand, that part of the table that goes to the ground. It would have a smooth transition from one part of the table to the other, and then it would be able to go down the ground. he used that to study projectile motion. Okay, and I know projectile motion is when there's no force acting on the thing other than gravity. And in this case, you got the table there. It's not the same. But the idea is that's only being used to slow down the motion, just like Galileo used a ramp to study free fall. If something goes down an incline, the motion is slowed down so you can better measure how fast something's being pulled, especially at the time. I mean, now you got all these clocks and stuff, but if you go back to the basics and figure out what you need to know before you can get a clock, an accurate timepiece, this is part of it. Because Galileo, he was the one who invented and developed the pendulum as a means of measuring time. You know, they had maybe sand clocks and stuff. And what, I forget at the time, they might have had clocks in towns that were driven by weights inside, but it was only so accurate. But they needed something more accurate. And he figured out how he can compares the pendulum to his heart rate, and then learn about pendulums, and then use pendulums to keep track of time to measure heart rate. You know, if a pendulum goes back and forth a certain amount of times, it's like a minute. How many heartbeats did you have in the minute? So some of that was just being developed in the first place. He had to use like a water clock or an amount of water to measure, like as a analog to measuring time. You know, he didn't have like watches and all this stuff. So when he'd have something go down a ramp, he'd have a certain volume or weight of water, and he'd see for different angles of ramp, you'd have an amount of water, and that would indicate how much time it took. So that stuff wasn't there. So if we're developing from basics, we're going to that level. We don't have a time thing and all that. So to figure out what kind of shape something is, we need a way to slow down time. I mean, a way to slow down the motion. So it would be a ramp. And just as going down a ramp is not actually free fall, still yet it's going to like slow down free fall. And just like the situation where a ball would be projected off one table and then go onto a slanted section of the table onto the ground, it's not actually projectile motion, but it's like slowed down projectile motion, so he can study it. And then he figured out that it's in the shape of a semi-parabola. It's not a hyperbola, it's not a circular motion, it's not elliptical motion, it's not like a quadratic parabola, you know, like x to the fourth instead of x squared. It's specifically parabolic motion, semi-parabolic. So with the examples, we can understand what's going on. And even if I don't discuss that, still, once I discuss what examples of projectiles are versus what's not, it makes so much sense. Then students can start to get it. Then you can start to see, okay, look, when I get this thing and throw it upwards and it comes down, it goes up. Okay, first of all, it keeps going horizontally the whole time, but you see it goes up and then it comes down. If it's going upwards and then it comes downwards, it's just moving away from you. Then it's got to stop going up. There's got to be a place where there's zero velocity. If it was not zero velocity, it would continue going up. Just look and see. Look at reality and see the thing, see the example. Then you can see that that's what happens. With a cannonball, with a bullet, with an arrow. You get something, it goes upwards and then it comes downwards. Or to focus on that part, get a marker, throw it up, and catch it. So it's kind of like free fall. You get it, you throw it up, it goes up, it stops, and it comes back down. So there's got to be a place where there's zero velocity. And that's what's happening with projectiles. Then students can start to do the physics. So there are some examples there I've used where examples are important. So there are some examples of using examples. It's important for teaching, learning, thinking. And we can see what's going on here in these with adjectives and with projectiles that'll help us in other areas. Again, those two things are something we can all think about, we can all dig into, and get logical characteristics of that we can apply to other things. Other things you're teaching, other things you're learning, things you have to do at work, things that are important in life, like knowing what a psychopath is. Because, unfortunately, there's too many of those out there. It's good to know what a psychopath is because you got coworkers that way, people you meet that way, bosses that are like that. It's good to know what one actually is, so you know how to deal with a person, you know who is and who's not. You know what friend is, besides some technical things specific to a certain field of thought or a certain career, there's things we all need to know about, like friend, discipline, money, honesty, integrity, wisdom versus like psychopath. What is a friend? And we all probably have some awareness of that, thinking someone's a friend and finding out they're not. We got to be careful about characterizing things correctly. Although, of course, we're not omniscient. People can lie to us. It can be hard to see that sometimes, who's a friend and who's not. But if we have focus on examples, we can get a better idea and judge people better. It's important to know what integrity is and honesty are. Have specific examples of situations and people. And we can see, just like with adjective, oh, this person, is it like these people who are friends? Like these people who have integrity? Or is this person different? It's important to make some of those classifications and comparisons explicit. But if we look at what we did with adjective and projectile, hopefully we can see that we need to see what some things are in contrast to others. And part of this kind of goes together. You don't just do one or the other. Contrast isn't separate from similarity. They're working together. Same thing with context. You can identify some of them logically a bit, but it's all wrapped up. Perception's all there. As Dr. Leonard Peikoff has said, science is nothing more than the conceptual unraveling of the evidence of the senses. So the stuff is there. Some stuff is going on at the same time. So we don't necessarily have, here's similarities without difference, or similarities without contrast, or similarities without context. The context, the contrast, the similarities are there. Some of that implies each other. Can't happen without the other. But we can focus a little bit more on the similarities when we got context and contrast. We can focus on some contrast when you got some similarities and context. But we see, if that makes sense to you, the more you think about it, when you understand, you'll get it. But with projectiles, we can see what these things are. Rocks, cannonballs that are like rock thrown, cannonball fired, in contrast to a jet or something that falls. We can start to see what's essential by contrasting and by putting them in context. Seeing that it's, as I said already, in the air, in a local area, when only an initial force acts on something and then gravity pulls it down. So in studying things, like I say, think about what are examples? What's their nature? How are they similar? how are they different from related things? What's the contrast? What's the context? What's the causation involved? That'll help you understand. So it's having examples and then using the examples to drive thinking, drive concept formation, drive understanding. Again, get the examples and see what is their nature, how are they similar, and how are they different from related things. Like how is an adjective, how is this kind of word different than these other words that are adverbs, these other words that are nouns, these other words that are verbs, what's the contrast? And then what's the context? Adjectives, you're talking about language. Projectiles, you're talking about the physics and motion of things. And what's the causality? What makes it happen? There, with adjective, I was just talking about classifying, not forming propositions, getting inductions. But with projectile, then we looked into some causality, getting the concept of projectile and using it to see all projectile motion is in the form of is a parabolic motion, I should say. All projectile motion is a parabolic motion. Then we're getting some understanding, bringing in causality. All projectile motion is motion where an object is pulled down vertically by gravity, things like that. So there's some things we can do to get better understanding of something, to help students learn, to help us teach better. Use examples to do so. Get an example and then start thinking about what those things are in contrast to others, how they're similar, what defines it, what the causality is. I hope that helps. So thank you for listening. Have a good one. Bye.